Aiming to make quantum leaps in technology, engineers in New Jersey are reinventing an arcade classic from the inside out. They're making sure that with these machines, anyone could sure play a mean pinball. Hello, I'm Justine Murphy, and this is Light Matters for July 25th, 2016. The pinball machine is an arcade staple, with that little silver ball rousing the distinct bells and dings and flashing lights. Now, innovators at Jersey Jack Pinball are reimagining that old familiar game. With LEDs and other updates, the company is rolling its machines into the modern age. We'll have that story a little later in the show. This month, we also take a look at new touch-based and breath-based sensors for vehicles that aim to prevent drunk driving. And managing editor Michael Wheeler is here with a sneak peek at the August issue of Photonics Spectra. He'll also talk about Photonics Media's new beacons recognition program. But first, a new light source technology could become the basis for establishing a secure global quantum network in space, reaching the ends of the Earth. A team from the National University of Singapore and the University of Strathclyde in the UK has developed a technology that could potentially launch a quantum network in space that spans from one end of the Earth to the other. Ultimately, the technology may be able to preserve the quantum properties of light as it travels through an optical link from space to Earth. The researchers built a space-qualified light source that could fit on a nanosatellite by redesigning a tabletop quantum setup to be small and robust enough to fly inside a satellite the size of a shoebox and weighing just 1.65 kilograms. In their work, the team demonstrated the in-orbit operation of a photon pair source aboard the nanosatellite, laying the groundwork for future entangled photon experiments. The device inside the satellite, known as a small photon entangling quantum system, which comprises a laser diode, crystals, mirrors, and photon detectors, takes photons from a blue-ray laser and splits them in half, then measures the pair's properties.
Now, you cannot send light through an optical fiber or to the atmosphere for more than 100 kilometers before the quantum properties are lost. So one way to try and overcome this limit is to put a quantum light source on a satellite in space and then use those satellites to beam the quantum particles, the photons, down to receivers on Earth. So my research group has a roadmap where we're trying to build a platform that carries a quantum light source in space, and we actually are visualizing a global encryption network that's maintained by a fleet of these quantum satellites.
The researchers will conduct further testing and refinement, which may allow entangled photons beamed from satellites to connect points on opposite sides of the planet. A fleet of nanosatellites carrying these entangled photons could then enable private encryption keys between any 2 points on Earth. Backup cameras, lane departure warnings, and blind spot detection systems are designed to keep motorists safe. But what about using the vehicle to prevent drunk driving? A touch-based sensor system and one that is breath-based have the potential to do just that. NanoPlus Nanosystems and Technologies in Germany has been working in collaboration with the U.S. Automotive Coalition for Traffic Safety, as well as True Touch Technologies and TK Holdings to research and create these alcohol sensors. Takata True Touch, a partnership between True Touch and Michigan-based automotive supplier Takata, has developed the Driver Alcohol Detection System for Safety touch-based sensor system. It would be installed somewhere inside the vehicle in places natural to the driver, such as the gear shifter or ignition button, and can take multiple readings in less than a second. Another alcohol detection system in development, which would also be installed inside a vehicle, measures the amount of alcohol in a person's body through their breath.
The breath-based technology pulls the driver's exhaled breath into a sensor, which could be located in the driver's side door or in the steering column as the driver breathes normally. A beam of infrared light is then directed at the molecules in the breath. Carbon dioxide and alcohol molecules absorb different amounts of light, and the sensor can compare the two, making it easy to measure alcohol levels precisely, even at very small concentrations. If the proportion of alcohol molecules to carbon dioxide molecules is above a certain range, it indicates an illegal blood alcohol level. The location and precision of the sensors, combined with engineered cabin airflow, enable the system to capture and test only the driver's breath. The TouchBased technology reads blood alcohol below the skin surface. Touch sensors in the car's ignition button or in the gear shift shine a beam of light onto a finger. This touch-based system uses near-infrared tissue spectroscopy to detect the level of alcohol in the blood. Alcohol absorbs specific wavelengths of light. By measuring the light's intensity, the system can precisely pinpoint the driver's blood alcohol level.
If either system detects that the attempted driver's blood alcohol level is above the legal limit, the vehicle simply won't move. It could turn on, according to NanoPlus, but only for use of the heater or air conditioning. These systems are expected to become safety options in new vehicles. There's no denying the role light plays in pinball machines. You can see that in any arcade. The traditional models may not appear as high-tech as some of the video games there, but pinball is still an entertainer. And with continuing advancements in light-based technology, revitalization of these fun machines will create more captivating gaming. In 2011, pinball aficionado Jack Guarneri noticed a stagnating market for these machines, and he soon found that the ones out there were equipped with outdated displays and technology. In the early days of electronic pinball machines, dating back to the 1960s, the lighting and technology were simple, relying on incandescent bulbs, colored plastic playfield inserts and lenses, and other basic lighting components. According to Butch Peel, who engineers Jersey Jack machines and writes their manuals, pinball was still being made that way when the company began its work 5 years ago. But now, with the help of Jersey Jack, LEDs are bringing new light to pinball. The company's first new machine, featuring a Wizard of Oz theme, employs strictly RGB LED lighting, mounted under clear plastic playfield inserts, rollover buttons, and posts. Frosted or clear acrylic light rods wind through the playfield and provide general illumination to the surface. RGB LED chips are mounted to the bottom of each rod, allowing light to travel through and be diffused above, similar to a fiber optic effect. And a total of 139 individual controllable RGB LEDs are inside the game's playfields. This new pinball machine also touts an LCD monitor above in its back glass, allowing some cool effects in both attract and gameplay modes. This next generation of pinball machines, with their high-tech lighting systems, will have players flipping out.
Whether it's self-driving cars, optical computers, or ultra-fast telecommunication networks, these and other disruptive technologies require the further development of integrated photonic circuits. In the August issue of Photonics Spectra, we survey the integrated photonics landscape and profile the role of two promising yet distinctly different materials, silicon and graphene. With its suitability for monolithic integration of optics and photonics, silicon has garnered significant attention in recent years. Researchers have published important findings related to integrating 3-5 materials directly on silicon wafers. For its part, graphene, a 2D material with an incredible capacity for signal emission, transmission, and detection, is eyed as playing an important role down the line, potentially in modulators or photodetectors. But growing graphene commercially remains an obstacle. Learn more in Integrated Photonics, A Tale of Two Materials. Also in August, we unveil a new recognition program called the Beacons. Selected from nominations put forth by you, our readers, the distinction is reserved for those in the photonics industry who've made significant contributions in the areas of entrepreneurship, research, and education. Among them, you'll find a high school science teacher from Rochester, New York, who was inspired to build an ophthalmology lab to create glasses for students who couldn't afford them. Not only would he build the lab, but he would also create a thriving precision optics fabrication program at the high school, with an enrollment of more than 50 students. We also feature a postdoctoral research whose work in the golden window involves near-IR wavelengths for non-invasive imaging of brain and breast tissue. And, in a nod to those with an entrepreneurial vision, we highlight the co-founder of one of Germany's preeminent machine vision companies, whose contributions to object recognition software can be seen in thousands of manufacturing facilities worldwide. Be sure to pick up your copy of the August issue and visit photonics.com for video segments profiling each of the Beacon honorees.
Thanks, Mike. That's it for this month's show. Check us out on social media and drop us a line with your feedback and suggestions. Until next time, keep following the photons.